Okay, in this video we're going to take a look at the constant of proportionality. Constant of proportionality. After watching this video, students will be able to find slope, determine proportionality, aka proportional relationships, writing equations using slope, and finding that constant of proportionality. Okay, so what is a proportional relationship? A proportional relationship happens when two variables have a constant slope so when there is a constant slope between two variables. Remember, when we've talked about slope before, there have been other words that mean the same thing. Slope, rate of change, and unit rate are all the same thing. There's another word that means the same thing. This is the constant of proportionality. Proportionality. Sometimes that's shortened to the constant of p, but the variable that is used to describe this constant of proportionality is the variable k, which doesn't make very much sense, but that's the way it is. To find this constant of proportionality, because we know it's equal to slope or rate of change or unit rate, you could find any of those, so I'm just going to say find the slope, or you could also just divide y by x, and you would find your constant of proportionality. Okay, so let's figure out if these tables represent a proportional relationship, and if they do, find the constant of proportionality, k. The difference between all of my y's, remember we have an x column and a y column each time, is 62. That's my difference. And the difference of my x column is 1 every time. So when I go to write my slope, it's going to be 62 over 1 each time. Now we need to determine if this is going through the origin at point 0, 0. If I subtract 1 from 1, it equals 0. And if I subtract 62 from 62, it also equals 0. So this goes through the origin. Yes, this is proportional, and my k, the constant of proportionality, is 62 over 1, or you could just write 62. All of these are very, very different, which is normally a sign that it will not be proportional. But let's double check to make sure. On my calculator, I'm going to pick any of these. I'll just start at the bottom, 225 divided by 6. And that answer should equal any of the other pairs. And when I go to do that, I see that they are not equal. So since the slope is not the same the entire time, it cannot be proportional. The answer here is a big no. And the last one does have a constant slope, 4, 4, 4, 5, 5, 5, 4 over 5. And does it go through 0, 0? 5 minus 5 is 0, 4 minus 4 is 0. It does go through 0, 0. So because it does both of those things, this is a yes, and my constant of proportionality is 4 over 5, the same as the slope. use the information given to complete each table. Alex makes $12.50 per hour. So at the end of hour 1, he's got $12.50. At the end of hour 2, $25. At the end of hour 3, I should say 25. At the end of hour 3, $37.50. And at the end of hour 4, $50. So what's the pattern happening here? Well, they're just adding $12.50 each time. Or you could say they're taking the amount of hours and multiplying that by $12.50. So if somebody asked you how much would Alex make in 9 hours, you could just multiply 9 times $12.50 and get the answer. Same thing with these brownies. 1/2 cup of milk is needed for each batch of brownies. So if I have 1, that would be 1/2. If I had 2, that would be 2 halves, which is also called 1. If I had 3, I would have 3 halves, which is also called 1.5 or 1.5. And if I had 4, I would have 4 halves, 2. If somebody wanted to know how much milk you would need if you made 17 batches of brownies, 17 times 1/2. Next, if there is a proportional relationship, we can give it an equation. Using the variables x and y, and then the constant of proportionality k, we can use this equation, y equals kx, which actually looks kind of familiar. Last week we had the equation y equals mx, and guess what? These two things are equal to each other. K is the constant of proportionality, m is slope, and we learned earlier that constant of proportionality and slope are the same thing, so these are the same exact equation. Find your constant of proportionality and write the equation for each of these tables. My difference of y is 17. My difference of x is 1. So in number 6, my constant of proportionality is 17 over 1. Remember, we're writing y over x. Or you could just say 17. That's fine as well. And then the formula, y equals 17x. The equation for the slope of a line, or the equation of the proportional relationship, is always written like this. Y equals starts it out, then you write down your constant of proportionality or your slope, the number, and then you finish the equation with the variable x. Do the same thing in the next one. Find your differences. Here I notice that we actually have 2 numbers, so we're going to have what seems like 2 different slopes, but really they're going to be the same when we're all said and done. So we've got 72 over 9 and 48 over 6. We need to divide. 72 divided by 9 is 8. 48 divided by 6 is 8. Guess what? My constant of proportionality is 8, because both of these two things were equal to 8. Now that I know my constant of proportionality, k equals 8, I can write the equation y is equal to 8x. Same thing in the next one. Find your difference of y. Remember, y is always the column on the right, x is on the left. All of these differences are 75 cents. And my x differences will be half a pound. You can say 0.5 or 0.50. Write that out. That is your constant of proportionality. K is equal to 0.75 over 0.50. Think about it like this. Can this be simplified? Yes. Both of these are multiples of 0.25. How many quarters do you have if you have 75 cents? 3. How many quarters do you have if you have 50 cents? 2. So this simplifies to 3 halves. Or if you were to divide this on a calculator, 0.75 divided by 0.50 is equal to 1.5. So both of these are the answer. You don't have to write both of them, just one of them. And the formula would be either y equals 3 halves x, or you could also say y equals 1.5x. It really does not matter. Both of these are correct. You get to choose how you write it. You could leave it as a fraction, or you could write it as a decimal. It does not matter. Alright, when I take any of my ratios here, 1350 divided by 18 is equal to 0.75 or 75 cents. So that's my constant. It could also be written as the fraction 3/4, 3/4. And then the formula, I could say y equals 0.75x, or I could leave it as a fraction, y equals 3/4 x. Both of those mean the same exact thing. They are both correct. Moving on. The graph of a proportional relationship looks a particular way. It is a straight line. We've seen plenty of these before. That passes through a certain point. Always goes through the origin. Always goes through the origin, and it is a straight line. The origin, remember, is 0.0. And then if you have a proportional graph, there is something special you can do to find the constant of proportionality, or your slope. Given one of these graphs, pick any point on the graph and divide y by x. That looks like this. Should look familiar. So determine if the graph represents a proportional relationship. Is it a straight line? Does it go to the origin? And if that is true, which this one is, find the constant of k and write the equation. So I should be able to pick any point on here. It does not matter which one I pick. Any of these work. Let's just pick this one. Look at its y number. Divide that by its x number. There's your constant of proportionality, and that works anywhere, I promise. If I did this one, 240 divided by 12 also equals 20. If I pick the first one, 40 divided by 2 equals 20. So k is 20, and then the formula y equals 20x. Same thing in the next one. Is this proportional? Yes, this is proportional. It goes to the origin, and it's a straight line. Pick any point, doesn't matter which one. We've got 3/2, or we've got 1.5 over 1, which equals 1.5. So k is 1.5, or you could leave it as a fraction, doesn't matter. And then y is equal to 1.5x, or you could write it using the fraction. It really does not matter. And then 12, does it go to the origin? No, so we cannot find either the constant of proportionality or the equation that represents the proportional relationship. So if it's not proportional, you don't have to do any other work. Just write the word no. Okay, put it all together. For each problem, complete the table, write an equation, and then graph that. Troy burns 4 calories per minute At minute 0, he has burned 0 calories. At minute 1, he has burned 4 calories. 4 calories per minute. At minute 2, 8, and at minute 3, 12. I'm just adding 4 each time. So, what does this mean? The y difference is clearly 4, and the x difference is 1. So the slope, the constant of proportionality, is 4. Y equals 4x. Aha! And then if I were to go ahead and graph that, we have calories up here and minutes here. Start at 0, 0. Then we've got at minute 1, we are burning 4 calories. 1, 2, 3, 4. At minute 2, we are burning 8 calories. 5, 6, 7, 8. And at minute 3, we are off the chart. So let's go ahead and connect these together. Next one, do the same thing. Gas cost is $2.50 per gallon. So I'm just going to multiply 250 times each of these things. 250 times 0 equals 0. 250 times 5, use my calculator. 1250. 250 times 10 must be 2 times 5, so that will be twice as much as 5 was, which is 25. 0, 0. $25. And then the next one, we're multiplying 2.50 times 15, which is going to equal $37.50. All right, what's happening here? They told us what the slope or the constant was. It's 250, so y equals 250x. And I could graph this. Okay, let's count gallons on the bottom. We must, because that's the x column. And we've got cost on the left. And let's think here. At gallon, I'm just going to say that each of these is 1. So at 1 gallon, it's going to cost $2.50. At 2 gallons, it's going to cost $5. At 3 gallons, $7.50. And at 4 gallons, $10. And we didn't even get to any of the numbers on our table, but that's okay. Go ahead and connect these with a straight line, and we've got our arrow. Okay, complete the table. Use points from the graph. Easy peasy, lemon squeezy. Find some points. There's a point, there's a point, there's a point, there's a point, and of course we still have 0, 0 as well. And then just fill in this table. You've got our x and our y. This is obviously 0 and 0. If x is 1, it is equal to what? 15. X is 2, it is equal to 30. And if x is 3, it is equal to 45. So there's not going to be a ratio here for 0, 0. The ratio for 15 over 1 is going to be just 15 over 1. The ratio for 1 comma 15 is 15 over 1. The unit rate there is just 15. Simplify it. Next, the ratio for 2 comma 30 is 30 over 2. And again, we're going to simplify. It's 15. And 45 over 3 also equals 15. So my unit rate is 15 across the board. The equation y equals 15x. Next one. If you don't want to use 0, 0, you don't really have to. Just find more points. Use whichever ones you want to. You don't have to use 0, 0. We can use 2, 80, 4, 160, 6, 240, and 8, 320. Simplifies to 40. This simplifies to 40. Hey, I'm sensing a theme here. I think all of these are going to simplify and equal 40. What? It's true. It's true. Unit rate across the board is 40, and the equation y equals 40x. And one last example. Again, you can use 0, 0. You don't have to. Use whatever numbers you want to. Okay. Here we've got 3 blanks. You can use 0, 0 if you want to. You don't have to. I've got 1. What are they counting by here? 5, 10, 15, 20, 25. 2 is at 40, 45, 50. And 3 is going to be at 75, 180. I've got 25 over 1, 50 over 2, and 75 over 3. And yes, they all simplify and equal 25. My unit rate is 25. If they asked for the slope, I would say 25. If they asked for the rate of change, I would say 25. If they ask for the constant of proportionality, I would say 25. They're all 25. They're all the same thing. And then finally, my equation would be y equals 25x. And that is all I've got for today. Find your points, put them into the table, find the ratio, simplify that to get the unit rate or the slope or the rate of change, or the constant of proportionality, whatever they ask you, they're all the same thing, and then you can write your equation.